Hi, this is Mrs. Cribb. I need you to pull out your stoichiometry sheets, and we're going to go through stoichiometry sheet 5. We're going to go through question number 20 as an example, and you've been assigned the remainder of the questions at some point in the next couple of days. All right, so let's look at this reaction first of all. Notice this is two H2s. So that's the coefficient 2 in front of the H2. It looks a little weird, but it's there. So how many grams of hydrogen, so that's this stuff, so I put a question mark and put grams, are required to produce 145 grams of methane. And I told you what methane was. And I want to remind you of the flow chart. We have the mass of the first molecule, whatever that is, that's we call A. We turn it into the moles of A using the molar mass, whatever the molar mass of A is. And then we go from the molecule A to molecule B, the one we're asking the question about, using the ratio bridge. And that ratio bridge is the mole ratio bridge. Only the moles can walk back and forth across that bridge. And then we can change the moles of B back into the mass of B using the molar mass of whatever molecule B is. So here we use the molar mass of molecule A, and here we're going to use the molar mass of molecule B. Now molecule A is always the one you know about. So in this case, this methane is molecule A. It's going to be on this side. And we have the mass of A, of methane, 145 grams. Remember that mass is in grams. If it's in kilograms, you first have to change it into grams. So methane is molecule A, and the thing they're asking the question about is hydrogen. So hydrogen is molecule B, and it wants to have the grams of hydrogen. So I've got to go all the way through this process to get to hydrogen. So you always start off with what you know. So I have methane, and I have 145 grams of it. So the first thing is to turn the mass of A into the moles of A using the molar mass. So I need the molar mass of methane. So I can put that over 1. So the first thing I need to use is the molar mass of methane. So I calculate that. C and H, 1 and 4, because there's 4 atoms in methane, 4 hydrogens. 1.01, 12.01, 4 times 1.01 is 4.04. So I add those together, and I get 16.05 grams per mole. All right, so that's the molar mass of methane. So I want to know moles. Remember, I'm going from mass to moles. And whatever the unit is right here, I want to be able to cancel, so the corresponding unit has to be on the bottom, grams. So 16.05 grams goes on the bottom, and 1 mole goes on the top. And so now I'm going to do the canceling, and I'm going to cancel out my grams, and I have moles. Okay? So now I'm going to do the next step. So I've gone here for the mass of A, I'm now at the moles of A. So the next step is to use the ratio from A to B. And I get the ratio directly from the equation, like the recipe. There's 1 mole. That's what the coefficient stands for again, moles. There's 1 mole of methane for every 2 moles of hydrogen. And since hydrogen is the question, it's what I want, it needs to be on top, and also I need to be able to cancel out the methane. So I use 2 moles of hydrogen, and I make 1 mole of methane. Notice the methane is on the bottom, and it's on the top over here, so I can cancel them out. So now I'm going to cancel that out here, and the mole unit cancels out. So I have moles of hydrogen now. So that gets us, this is where we are right now. Now we need to go to the next step, turn it into the mass of hydrogen, because we just went from the moles to moles using the molar mass. This is right here, moles to moles using the ratio. This is where we used the mole ratio, and that got us across the bridge to change molecules. Now the last step here is to go from moles of hydrogen to mass, so I also need the molar mass. This time I need the molar mass of hydrogen. So hydrogen, and you notice it has 2 atoms in hydrogen, That's the subscript of 2. So 2 times 1.01 is 2.02. That's the molar mass of hydrogen, grams per mole. And since moles are on top, it needs to be on the one on the bottom. And this time the grams are on top, 2.02 grams. Now I can cancel again, and so I'm going to cancel moles and moles, and I just have the units left are grams and hydrogen, and that's what I wanted. It asked me for the mass. So I put these numbers in my calculator. 145 divided by, remember this is divided by, 16.05 times 2 and times 2.02, and I get 36.5 grams of hydrogen. Okay, that's the final answer. It has 3 sig figs because this number right here, the very beginning number, also has 3 sig figs. This very beginning number is measured. The other guys are all definitions. All right, please use this flow chart right here when you're doing these problems, and you'll have to do the rest of them. Good luck!